Okay, welcome everybody. I guess this monitor is still broken. Wow, it's really annoying. Sorry about that. So this will be an awkward exercise in looking at either me or at the monitor. So today we're going to talk about some more getting going with milestone 2. How many people have started on milestone 2? Okay, some haven't. Okay. All right, so it's fine either way, but I suggest get going soon. Okay, milestone 2 is more open-ended than milestone 1. So I don't know if it's actually more, it's probably somewhat more work, and it's also you can go farther if you want. Okay, so where we left off before reading week was we were drawing all the intersections in our city on our map. So I'm going to go out here just so I'm around. And we figured out that we need to reasonable coordinates, and we need our drawing to. And we decided that a reasonable way to draw this was to project everything into XY coordinates in meters on the surface of the Earth. And for, even though the Earth is curved, for a small section of the Earth, that's a pretty good representation of a map. So we did that, and it looked good. So this is the code we had. So take a look at this. We basically created a structure called intersection data that had the latitude and longitude of every intersection and its name. And we made a global variable, so we had one such structure for every single intersection. And then our most important function for milestone 2 is our screen redraw function, which we decided to call draw main canvas in our code. And that code went through, and for every single intersection, okay, so from 0 to the number of intersections, we went through and we computed an X coordinate and a Y coordinate by basically transforming the longitude and the latitude to a position on the surface of the Earth in meters with these nice little helper functions. And then we drew a rectangle. Okay, so we drew a rectangle where the lower left corner is that transformed point, and the upper right corner is 100 meters to the right and up. Okay, and we did that for every single one of our intersections. So 150,000 in Toronto, maybe 600,000 or so in Tokyo. Okay, so this all worked, so that's good. This routine is speed critical. So one of the things you're trying to do in milestone 2 is make your graphics responsive. And the by far most important part of that is that your screen redrawing function is pretty fast. So we'd like to really optimize this for speed. Is there anything in the screen redrawing function? So it's an order n computation. I'm going through all the intersections. So you go, okay, order n, that could be noticeable. And as the person interacts with the graphics, zooms in, zooms out, drags the view a little bit, hides the window, brings back the window, every single one of those things is a redraw. Things like dragging the graphics to pan them is actually a lot of redraws. Like as you're drawing it, as you're dragging it, it's redrawing over and over again. So we'd like this to be fast. What's the order of this redraw routine? So the computational complexity. So order 1, order n squared. What do you think? Any ideas? This is not a really, don't worry, there's no trick here. Okay, so if you look at it and go, it seems like this, that's the answer. What do you think? Yeah, it's order n, because I went through all the intersections. I can't really do, without a lot of really complicated stuff, I can't do better than this. I'm supposed to draw the city. I'm going to go through all the intersections. Okay, so your redraw function is, almost certainly going to be order n. I mean, there are some techniques you can use when you zoom in that make it even faster than that, but very few people will do those. Okay, so it's going to be order n. So we can't really get rid of that, but we can try to bring the constant down. Is there anything we could do to make the constant in front of that order n smaller? Yeah. Right, and that's a great idea. You're looking at this and going, I'm doing this X from lon, Y from lat, 150,000 times for Toronto, and they don't actually change as I redraw. These are like fixed. A certain intersection in Toronto has a certain latitude and longitude that projects to a certain X, Y. So I don't really need to do this on every redraw. I could pre-compute it. So I could put it in load map. That's a technique I can use to bring this constant down, get some better responsiveness. So before you do that, you should go look at, well, what's in those helper functions? Is this worth doing? Maybe there's not much in them and I don't even want to bother. And that's reasonable. You got to put a price on your own time. So we look at it, and let's just look at the longitude one. The latitude is similar. So longitude one, we've got a multiply, another multiply, another multiply, another multiply, and a cosine. Okay, so 4 multiplies and 1 cos. Okay, and we do this n times. So this might add up. Seems like it might be worth pre-computing. So let's do a challenge of teams here. So I'm going to take, okay, so I'm going to pick on your team versus your team. Okay, so we're going to have a competition. Okay, so I'm asking you a question, and this is a speed. Okay, so you ready? It matters, you can confer, but then give me one answer. Okay, what is 2 times 2? 4? Okay, pretty fast. Although you didn't have to think about it. You kind of looked at your partner too. You're like, I think it's 4, but not 100%. Maybe I'm compromised. So, okay, now your question. What is the cosine of 2? Don't know. Okay, but you guys already won. Okay, so it's just like this for a computer. Multiply is 1 cycle. So all modern processors can launch at least 1 multiply every clock cycle. It's a single instruction. Cosine is a trigonometric function. They're going to have some kind of Taylor series, or there are a few other techniques to do this, but it's going to be a subroutine. It's going to do a bunch of computation to approximate cosine to a high degree. It takes a lot longer. Okay, just like this was not actually, you might have noticed, this was not quite a fair question. You're like, wait a sec, what the heck? How do I get cosine of 2? I got 2 times 2. Okay, so the cosine is actually the biggest deal here. But I can't, so try not to be computing this cosine in your over and over again, hundreds of thousands of times, even millions of times in your redraw function. You can easily store it in your load map, right? Because it's just this whole thing is just one number. That's really easy to store. But I can get rid of all these multiplies too. Since I'm already storing the lat longs of these intersections, why don't I just store the xy's? Because that saves me even more time. So I'm going to go further, do exactly what was suggested. Let's just store the xy coordinates. Okay? So, because I really want this to be fast. In order for my redraws to feel really smooth, you probably want them, if you can get them down to 10 milliseconds, it means you get 10 redraws a second. That's going to feel pretty smooth. Okay? If you can get it to 100 or 50 redraws a second, it's going to feel extremely smooth, but you may not get there. You may not even get to 10, right? Tokyo, for example, is going to be really hard to get to 10. That's fine. Okay? But you just kind of want to make it as fast as you can. You won't get to a point where you go, I don't care anymore. You're probably going to find that even when you're done optimizing some, your map's still not quite as fast as you wish, but that's the way it is. Okay, so we can reduce this computation by moving code into load map. So we basically change this intersection data so that it doesn't store a lat long anymore. Instead, it stores an XY location. And I'm going to use a convenient class that EasyGL defines called point2D. So it's just an XY location. That's all it is. It's got a dot X and a dot Y. And I'm going to make a global variable, again, called intersections, but it's just of a different type now. And it stores the XY location instead of the lat long for every intersection. And now my code, my redraw code looks a little simpler. I go through every single intersection and already computed the low XY, so I just passed that in. So I've saved some code. And this fill rectangle function in EasyGL, there's a few different ways you can call it, a few overloaded versions of it. I'm going to call the version where I just pass in 1 point and a width and a height. And this is about as fast as I can go, right? I've pre-computed the X and Y. All I'm doing is looping through every single intersection and just saying fill rectangle, okay? Now, fill rectangle can take a little while. It's got a fair amount of work to do. It's actually drawing pixels. So, that is a reasonable amount of work. So if I want to get faster still, I'm going to have to try to just draw fewer rectangles, which is different optimizations. Okay, so let me quickly demonstrate that. So, and it's going to look just like what it looked like before reading week. All right, so here's my code. And here's my draw map function. I've written a few different ones. This is one that does faster projections. Okay, so hopefully remember this from before reading week. But we had to pre-compute the bounds of our map. So the maximum latitude, the minimum latitude, etc. And I'm now using a helper function to do that, which is what you guys should do. Try to keep your functions short. So in a helper function, basically this is the function that now sets up my graphics window, okay? And I'm calling a helper function, which does exactly what we talked about before reading week, find the maximum minimum latitude. And now it does a little more. So it finds the maximum minimum latitude, the average latitude, and then it goes through, and for every single intersection, it computes this X and Y, and it stores them in this intersections variable. So it's not very complicated. Okay, remember you got a little bit of setup code to write to get the graphics windows going. So we talked about that before reading week. It's the same. Set my initial coordinate system. I'm going to connect my callback function for my main drawing area. I'm calling it this name, draw main canvas faster projection. And then when I call application.run, that's going to pass control to EasyGL, and it's going to call my redraw function whenever it needs a redraw. So let's go look at that redraw function. And basically, it looks just like what I showed you, okay? It sets the color to black, goes through all the intersections, and it quickly draws them as filled-in rectangles, you know, using their lower left point, that XY that we pre-computed, and a width and a height. I've also put timers in here. So as you're trying to speed up your graphics, it's useful to put timers in. So I showed you the code for this in lecture. It's this chrono library. So I basically get the time before I start drawing, I get the time after I stop drawing, and I print it out. So I can tell how fast this is. Okay, and let's see. So if I build this and run it, it'll hopefully remind you of what this looks like. Okay, so the projection all looks good. And you can see as I do various things, I'm getting redraws. So hopefully you can see this down below. As I move this around, you see draw main canvas took this many seconds. There are a lot of redraws happening. Okay, so this hopefully gives you an idea of your redraw gets called a lot. Let's do, okay, so I just did a redraw. It took 0.006 seconds. So that's pretty fast. So if I didn't have anything else to draw, you know, I'm probably done. This is great. More than 100 frames per second, you'll never notice a difference. No point in optimizing this. But I haven't drawn streets yet and so on. So that's why we're optimizing. As we zoom in, okay, you see the redraws are actually getting faster. Okay, so the redraws are actually now down to, instead of 0.006, they're actually down to about 0.014. So about, you know, maybe 4 times faster because I zoomed in. You just saw my redraw function. I don't actually have any if statements about if I'm zoomed in or anything. Like I always do the same thing. So why did it get faster? Any ideas? Yeah, why do you think it's faster? So say it loud. So there's less stuff that's on the screen, right? Yeah, fill recs and basically all the EasyGL calls get faster if the stuff is off screen. So I'm going through all the intersections. But the first thing EasyGL does is does a quick text. Any chance that this rectangle or polygon or whatever is on, if it oh, there's no chance, which is basically it checks, is the whole thing past the right edge of the screen, is the whole thing below the bottom, is the whole thing above the top, is the whole thing left to the left. If it fails any of those checks, it never even calls the underlying Cairo and GTK rendering routines. Okay. It means you don't have to do those checks. If you did those checks, you're just wasting your time because EasyGL already does them. It means you naturally get faster as you zoom in. We're still spending some time, obviously, going through all the intersections because we are still going through and making this call to fill rec. The fill rec is faster because of this pre-clip. Okay, it means if you're timing your graphics and trying to speed it up, check both zoomed out and zoomed in behavior. They can be different. Okay, and then if I go do zoom fit to zoom out again, it goes back to 0.006 seconds. But it's pretty fast. All right, so let me go back to my slides here. Okay, so I also measured this for the code we had before reading week, which didn't pre-compute the XY. It just computed it every time in the redraw routine from lat long. And I got a reasonable speed up. So I measured this on a different computer, but basically, when the whole map was displayed, when I'm zoomed out, it sped up by about 1.5x. And when I'm zoomed way in, it sped up by about 2.1x. So it was worth doing it. And as I said, if this was all I had to draw, I probably should have just looked at it, my original numbers, and said, it's good enough. I mean, who cares? Nobody's going to be able to tell the difference. But because we're going to draw more things, this difference actually can be helpful to me. Okay, so we can get some speed up there. Does it make sense? Okay, so I'm not going to talk, next week we're going to talk about profiling and techniques to find where to spend your time. Okay, so some more about optimizing of redraw speed. I showed you one technique, pre-compute what you can. Your most powerful technique is level of detail modeling. When you're zoomed way out, don't draw everything because the person can't see it. You're just wasting time. In fact, it can be annoying. Like you're drawing more stuff than the person could possibly understand, so why are you doing it? So that's your big hammer for speeding things up. And as I said, we'll talk about next week how to measure where does your time go. But one of those techniques is to actually just put timers in your code, which you already know how to do. Okay, so any questions on that, or it's all pretty clear? Yeah, I'm going to take that as you think it's pretty clear. Okay, so that's about drawing. It's not the only thing you have to do in milestone 2. You also have to interact with the user. So let's talk about how you react to mouse clicks. So if you remember the code I just showed you, when we handed control to EasyGL, we use this application. Application is the EasyGL object that we created, and we call its run method, which hands control to it, and it's now going to see what the user is doing in terms of pressing keyboard, pressing the mouse, whatever, and just make callbacks, call us when it needs a redraw. We can tell it other callbacks, so functions that should call when certain things happen. So we're giving it one more callback now. We can send 4 callbacks into EasyGL, as well as the redraw routine. The redraw routine we always have to give it, not optional, but there are 4 optional ones. And we can use null pointer if we don't want to use them, or we give it the name of a function if we do want to use it. So I'm now saying I want you to call me when the mouse is clicked, okay? And this is the mouse is clicked on that main canvas, the area where we're drawing the screen. If the person clicks the mouse on one of the buttons, EasyGL will already handle that. They're clicking on your graphics. So EasyGL doesn't know what to do unless we give it a callback, in which case it'll call us. Okay, so now we have to write this function. So we can use any name we want. It's just whatever name we use for that function, we have to pass into application.run. Way this actually, do people know how this actually works, or do you care? Because maybe I'm going to tell you anyway, and afterwards you can tell me if that was a pointless digression. So sometimes students are confused, like, well, how can you pass a function to a function? Like, this seems kind of bizarre. You know, this is a function, and I'm passing another function to it. What does that really mean? Okay, so in C and C++, when you pass the name of a function, what the compiler really does is it passes the address at which the instructions for that function start, okay? And that's all it needs. So EasyGL now knows the address where the instructions for the function that should be called when the mouse is clicked are. So it can, in 243, have you learned about jumps to subroutines? You learned that instruction yet? Okay, so it does a jump to subroutine to that address. And it works fine, right? All it really needed was a memory address. And that's the way it interprets this name. Now, the function has to take the right parameters. So you're allowed to change the name, just whatever name you put here, you put there as well. You're not allowed to change the parameters, because that's how EasyGL is going to call it. It's going to put those parameters on the call stack, so your function must take them. No more, no less, no difference. So it passes in a pointer to the EasyGL application. That's because if you want to do anything with EasyGL, you need that pointer or you can't call anything. It passes in a pointer to a button event. You can use this or not use this. It basically allows you to get information like, is it the left mouse button, the right mouse button, was shift held down, was control held down? So if you want, you can get more information. And you could do things now like have, shift click to do this, right click to do that. You can do different things. And then the most important thing it passes you are an X and Y location. That's where the mouse was clicked. This is in world coordinates. So it's in the coordinate system that you selected to use. So it's going to be in meters on the surface of the Earth for our maps, because that's the coordinate system we chose. Okay. So I've already put in a little bit of code here saying print out where the mouse was clicked. It's actually good when you're debugging this to have your, have your callback tell you what's going on. Makes it a lot easier for you to figure out how your program's behaving. And then I'm going to print out what the closest intersection name is. How did I find the closest intersection? So what code would you put in here? How would you write this? Any ideas? The size of the box tells you it probably isn't too much code. There's a way to write this with not many lines. So what do you think you can do? And one of the things you'll notice, yeah, go ahead. Right. So you can use a function from M1. So M1 was, partly a learning exercise. Learn how to choose appropriate data structures, learn how to talk to our APIs. And partly, you build some functions that will be helpful to you. So which function is going to be helpful to you from M1? So what's the function from M1 you want to use? Right. You wrote a find closest intersection. What does it take as input? It takes a lat long. I just got an XY. What are you going to do? Yeah, so exactly. So you already wrote a routine. We already showed a routine in a tutorial about how to convert from lat long to XY. All of you know enough math that you can basically invert that linear equation and basically write a function that takes XY and gets you lat long. So that's exactly what we're going to do. So I'm not going to show you the function, but basically I wrote a couple of helper functions, lat from Y, long from X. And then I turn those into a lat long. So I just pass them into the constructor for a lat long, give the variable a name, pause, and I call my M1 function with that. So I can do it with 2 lines of code. Now, I didn't show you the helper functions, but the helper functions are pretty short. So there's a few different ways you can write those helper functions. You can write one helper function that turns a whole XY into a lat long all in one shot. Maybe that's cleaner. Doesn't really matter. Yeah. 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 So the way I've written this is I will always give an intersection. Okay. It's going to be the closest one. So no matter where I click on the map, it's going to return something. Okay. You're raising a good point. You're saying maybe if you're far from an intersection, you should just return some value like that means no intersection. And you could write that. So you're right. So you could write a different find intersection that knew how big you drew things and basically checked, are you actually in the box or not? And if you're not in the box, you didn't select anything. And if you are in the box, you did select something. So you're right. You could write that, and maybe that's better, actually. If you do that, make sure like my width and height right now are local variables. I should make sure that I make some kind of defined constant that is like my width and height. So both my hit test routine and my drawing routine are using the same constant. They don't put 100 in 2 different spots because that's fragile. And at the least, your TA will be unhappy with your style. And at the worst, somebody decides 100 is too big and they would go to 50, and now your drawing and your hit testing is out of sync. But yeah, good idea. I mean, that would arguably be a nicer hit test where you actually checked, are you inside the box that we drew? Does that make sense? The logic would be relatively similar, though. I mean, what you probably do is you might find what is the closest intersection and then just do an additional check. Am I inside its box? Yeah, because that's probably kind of the easiest way to write that. Probably also might actually be the fastest too, right? Because you find the closest thing and then you do a little bit of extra checking just for that one intersection. Now, the speed of this one doesn't matter very much. Okay, so redraw speed matters a lot. Humans can't click mouse very fast. So sometimes students will go off and they'll try to optimize this routine, which you can do. It's not wrong, but it's kind of a waste of your time. Which means this might take a fraction of a second. You just can't click a mouse that fast and actually interpret what comes back. No one can read that fast. So don't worry about the speed of this one too much. Okay, so makes sense? Everybody's got how this works? Okay, so well, that found the intersection that we clicked on, and we can print it out. But I'd actually like to do more than that. If you read the milestone 2 handout, it says you shouldn't just print out what a person clicked on. You should highlight it in the graphics. And maybe you give some information in the graphics. You could print to the terminal, which is what I'm doing right now, but maybe I want to show the information in the graphics. Okay, so how would I do that? I found the intersection when the person clicks. How would I show what they clicked on? What do you think? If you got some ideas, don't worry. It's not that complicated, but there are a couple ways you might think of doing this, one of which is going to work well and one of which is not. What do you think?
Inside that struct that represented like the extra thing, like when it goes through and renders each intersection, it renders the color variable there.
Yeah.
And then when we click on the closest intersection, we update that color to stay red instead of black.
Okay. So that makes perfect sense. And this is actually the good solution. So I'm going to repeat it in case you couldn't hear it. It's basically, we already have this, let me go back and look at it. We already have this data structure intersections. So we could put some additional information in here, put like a color for every intersection. And when somebody clicks, we could update that color for that intersection. And now our redraw routine could look at it and it'll draw things in the right color. And that's actually the right way to do it. Okay. So good answer. Something that students often try, because it seems like it should work, is they'll try to put drawing routines right here. They'll basically do some kind of fill rect, of something to do with this ID. Okay, maybe like set the color to red, and then they try to draw the intersection. Okay, that's the wrong thing to do. Why is that the wrong thing to do? I mean, it's not completely wrong. It'll do something, okay, and it's better than nothing, but it's not really the right way to attack this. What's wrong with that? Because it seems kind of easy. It seems kind of intuitive. You just figured out which intersection it is. Why don't I just draw it in red right here? Why do I have to do this whole thing of setting some variable and a redraw function draw it? What do you think?
The next time you redraw, it's just going to get overwritten by a new black one.
Yeah, that's exactly the problem. Draw it here, it'll draw once. Okay, and the mouse was clicked. Redraw, and I just showed you somebody's zooming out, dragging the graphics around, they obscure the window, they're drawing all and this highlight is going to disappear. As soon as that happens, your TA is going to check for it. So if you see on the rubric even, this is like, TAs know to check for this. Every year we'll have a few groups that argue this was interface, like I clicked on it, and then if you do anything, it disappears. Your TA is not going to buy it, right? There's no program where you start typing stuff in Microsoft Word, you saw the window, it deletes your text. No one has a user interface like that, right? It's not usable. So seemed like a good idea, but yeah, this is not quite right. We need to do what's called stateful graphics, okay? Okay, so what are our steps? So we're going to highlight an intersection when it's clicked. We're going to draw it in red. The first thing we need to do is we need to register our callback function. So we can't do this ourselves directly because EasyGL is in control. So we tell it when the mouse is clicked, call this function. Well, I already showed you how to do that, right? That was pretty easy. We just passed the name into application.run. Okay, now we actually have to write the callback function. So find the intersection closest to click. Already did that. So that's good. That's good. Talked about why did we not want to draw it. So don't draw it. Instead, just record it as highlighted so that future redraws get it right. And then we need to do this. We need to modify our screen redraw function to actually highlight it. Okay, so let's look at how we do this. So registering the callback, I already showed you that. It's pretty easy. Give it the name of the function. The second argument to application.run is the callback that gets called when you click the mouse. In case you want to use any of these other callbacks, here's the general form of application.run. So the first argument is a callback that will be called when the graphics window is first set up. So you can use this if you want to make extra buttons, extra UI elements to just basically say, okay, there's more setup to do. It'll be called once. We just talked about this one. This one gets called whenever any mouse button is clicked in your main canvas, your drawing area. You could also register a callback that just gets called whenever the mouse is moved. inside that graphics area. And you can use that to do like tooltips, like actually show some information when you're just hovering over things. So you don't have to use that, but if you want to, that's there. And this act on key press gets called whenever somebody hits the keyboard, any key on the keyboard, and the mouse is in your main drawing. Okay? And now the person can type stuff and you can respond to it. All right, but we're only going to use this one callback at this point. And you may not use all these callbacks. The fact that I show there are 4 callbacks doesn't mean, oh, I got to use them all. If you have no use for some of them, don't just leave them null pointer. Okay, so we already did this. Find the closest intersection. This is the same code that I showed you. It's in my click on mouse callback. And whoops, I messed up my graphics here. So let me quickly change this. This is supposed to be over this. Okay, so actually setting a variable. So the suggestion was put a variable in or a data member in this structure for every intersection that gives its color. I didn't do that. I just put a Boolean that says whether it's highlighted or not. Might actually be better to make one that says its color. Not a bad idea. It's a little more flexible. But I didn't do that. I just have a bool. Highlight or not highlight. I want this to be initialized to false. The reason I want it to be initialized to false is I want to start out with nothing is highlighted. Okay. And then inside my mouse click function, I basically can set highlight to true for the one ID that you clicked on. Okay, so that's the only change I've made to my mouse click function. Is everybody with me? Now, one thing that I'll just give you a quick warning about, sometimes students are tempted to put this equals false right there, right in the structure definition. That equals false basically is like a constructor, right? It basically, when this object is created, that variable will be initialized to false. So it seems very convenient. It's not wrong, but it's not enough. Why is this not enough for your purposes? So we want to set this to false in load map. Load map would be the most logical place to do it. So we set all this data structure up in load map and we set the there. Why do we want to set the false there rather than just setting equals false to have or the initialize? Any ideas? This isn't wrong. It's not going to cause you any problems. Except that it often gets students into trouble because this false is only done when this variable is created. Okay, this is a global variable that's created at the start of the program. So if your program is able to load more than one map, which often you do, you might have a load map button in your user interface, then this highlight will be set to false, for the first, when the program first starts running, but not if you load a new map. It doesn't get set again. This is only done on creation of the variable. So just remember that for any global variables you have, it is better to initialize them in your load map, because if you initialize them in the constructor or with these, I forget if this is called the constructor or the initializer specification, it basically is the same thing. It only happens once at the start of program, which usually isn't enough for you. Yeah. Yeah. Yeah, so good question. So let's repeat that. So the question is, if I click on a second intersection, should the first one go back to black? And that's a design choice. So you can decide what you want to do. You might say, well, I should only ever have one intersection highlighted, so I'm going to turn off the previous one. That's reasonable. You could say, no, I want to have the person be able to click on 20 intersections. I'll highlight them all, so I'm not going to unhighlight the previous one. That's also reasonable. Both of those are defensible decisions. You might highlight the most recent one in a different color than the other ones, which I can't do with my data structure, but the data structure you proposed where you actually store a color could do that. You could actually check in this routine. I haven't done this, but by examining this event data structure, which is documented in GDK. So if you basically go do a search, you'll find the definition of this data structure. You could check is shift held down. So you could say, okay, well, if they hold down shift, I will not de-highlight the previous thing. And if they're not holding down shift, I will de-highlight all the previous stuff. That's actually a pretty common convention that programs use, that shift click means I can select multiple things. Regular click means only one. All of these are reasonable things. Does that make sense? You could also put a button in your GUI that is clear all highlighting. So you might say, whenever you click, you keep highlighting more and more stuff. You should have some way to get rid of it. Okay, so if there's no way in your program to get rid of it, you just say, you just keep clicking, there's more and more highlighting, and there's no way to de-highlight, that's not good. So either second click de-highlights it, or there's a button to say clear all highlighting or something. They're all reasonable choices. Just make sure there's some way that it de-highlights. Okay. Yeah, so does this make sense? So I'm basically just storing in this state variable that I've highlighted this intersection. Okay, the next thing I need to do is I need to actually change my redraw function. And the change is not very complicated. So I already had this code that goes through all my intersections, and it draws a rectangle at that intersection. I just add this code. If that intersection is highlighted, let's draw it in red. Otherwise, let's draw it in black. EasyGL has multiple ways to set colors. You can set them with RGB values. There are also some predefined colors with names. I'm just using the predefined colors with names here. Okay, so let me go and demonstrate that. It's a good idea when you're doing graphics. I mean, it's a good idea in all programs, but it's maybe even more important with graphics. Write a little bit of code and then test it. Okay, see if it does what you expect. Because if it doesn't do what you expect, well, you know what code you just added. You know exactly where to start debugging. So I'm going to write, I wrote that much code, and I'm going to show you what it does. All right, so I've already pre-written this. I'm just going to comment out that version and build this version. And it basically just has the changes that I showed you. Okay, so let's run this. Okay, and make this a little bit bigger. And I'm going to zoom in a few times so I can see the intersections better. Okay, so you see where my mouse cursor is? I'm going to click on this intersection. Okay, so I clicked on it, nothing happened. Okay, so that seems kind of depressing. All that code seemed like such a good idea. But now I'm just going to zoom in once. Now it's red. Okay, okay, see where my mouse cursor is? I'm going to click on this intersection. Again, nothing happened, but I'm going to drag the graphics over a little, and now something got highlighted. It's a little bit behind another intersection. Let's click on this one, nothing happened. Drag it over. Click on that one, nothing happened. Drag it over. Okay, so what's going on? It kind of works, but it kind of doesn't work. What have I done wrong, or what am I missing? Like, what I've done is actually basically right, but I'm missing something. There's something I forgot about. Yeah. Yeah, okay, so let me just repeat that. I don't redraw right away. I basically record this is highlighted, and the redraw routine now knows to draw it in red. But what if the redraw doesn't happen for a while? User doesn't get any feedback. So that's confusing. So how can I fix this? So let me just hit proceed here, get out of this program, and we'll go back to the slides. Okay, so yeah, how do I fix this before I show you on the next slide? So use the, sorry, that again? Okay, so you're saying redraw using the application pointer. Is that right? So yeah, I need to redraw in my callback as well. So I need my mouse click routine needs to force a redraw, okay? Because you want something to change as soon as the person clicks. There are basically two ways I could do this. So I could take the drawing code that I've already written inside of the redraw routine and kind of paste it in here. That's going to be a mess. Okay, like you don't want to do that. Now you've got duplicated code. So what I want to do instead is just force a redraw. And that's a common enough thing that EasyGL just has a one function to do that. So you take this EasyGL application pointer that was passed into you, and you call its member function refresh drawing. And refresh drawing forces an immediate call of your screen redrawing callback, so you get an immediate update. So anything that changes your graphic state like this in a mouse or button callback, if you want the screen to immediately be updated, call this at the very end of the routine. Okay, does it make sense? So that's pretty easy. The other thing I've added in here, the previous code was, I didn't actually show this to you very well, but it was actually printing to the terminal what was I clicking on. So I'll show you when I do the next demo. But it was just printing it to the terminal. Might be more user-friendly to actually show this in the main graphics window, so a person doesn't have to go look at the terminal. So EasyGL gives you a single line of output called a status bar at the bottom of the window. So that's pre-set up for you. It's easy to use. So basically, if I can make a string that has what I want to print, instead of sending it to the terminal, I can just send it to that like status bar area and have it print in the graphics. So I basically have done that in this code. Do you guys know from 244 what a string stream is? Okay, yeah, so I see you nodding your head. So string stream is just like cout, a stream, but it goes into a string. That's all, okay? So I made a string stream. I've basically written to it same way I would write to any stream, like cout. So I've said intersection selected and its name. And then string streams have this function, .str, which gets the string. So you basically have used string stream to format a string and use the .str to get that string back out. And I pass that to a routine called update message, which I access through the EasyGL application pointer. So it's a member function of that class. All this is put that message at the bottom of my window. Okay, so you've got a really easy way to show one line of messages. If you want to do more messages, you can go in and make other user interface elements if you wish, but it's really easy to do like just single line ones is preset up for you. Okay, so let me demo that. Okay, so I'm just going to comment out the second one. And we'll do this third one. Whoops, I think I went too fast. Try that again. Okay, and this time I'm going to let you see what's going to the terminal. Okay, so if I click on something, it should highlight right away right now. So I click on that, and it did highlight right away. Let's zoom out, and basically you see it's printing things down here in the terminal. I didn't show you that before, but I printed out what are the XY location of the mouse. I print out when I've converted that to lat long, where is it? And then I print out the ID of the closest intersection. And this is probably a good idea as you're developing your UI to basically have some messages so it's telling you what's going on. You can run in the debugger and watch things, but it's also useful to have it just talk about it. Okay, I can click on multiple things, and you see I'm always highlighting different intersections. And if I zoom in and out, they stay highlighted. So this looks good. The other thing is, let's click on this intersection. Look in the lower left corner of the graphics over here. So when I click on something, I now see its name. So it says that's Delavan Avenue and Spadina Road. That one is Frybrook Road and Forest Hill Road, and so on. Okay, so I've got a pretty easy way now to display some text in my user interface with that update status bar. I haven't got any way to clear the highlighting, so you should actually have some way to do that. We talked about that earlier. And let me show you one last thing. All right, so if you can see where my mouse cursor is, you can see that I am I'm inside a certain rectangle. When I click, it's highlighting the one next to it. Okay, let me try that again. So I'll go over to this rectangle and click on it, and it does the one next to it. Now I go over here, does that one. Seems like it's that one it got right. Okay, so it seems that sometimes it's getting the intersection I would expect, sometimes it's getting one that's nearby but not expect. So what's going on? It seems a bit counterintuitive. Kind of highlight the intersection near where I expect, but not necessarily the one I expected. Although sometimes it is the one I expected, right? So let me maybe go over to some place where there's fewer intersections, so it's more obvious what's going on. Let's go here. Whoops. Let's see, let's zoom in here. Yeah, so if I click on this one, for example, it highlighted the one above it. Click on that one, it got it right. Click on this one, it gets that. What do you think's going on? Yeah.
So our actual intersection location is at the corner of one of those rectangles?
Yeah.
That's what it is?
Yeah, so I haven't really lined up my mouse clicking in the drawing. The way I drew this is I drew from the intersection is at the lower left corner, and I drew 100 meters up and 100 meters to the right. But when I call my find closest intersection, it just finds which intersection is closest. It's actually finding what is lower left corner that is closest. So it's a bit misaligned. My drawing and my selection are misaligned. What can I do to fix this? There's a really easy fix. There's lots of ways you can fix it, but one of them is really easy. Can you say that again? Right. Okay. So make the intersection the center of the rectangle. Just change my drawing. And yeah, that's the best way to fix this. It's the most visually logical and by far the simplest way to fix this. So I shouldn't draw things like this. It's better for me to draw them centered. So let's go back and I'll show you what the code for that looks like. Not much of a change. Okay. Yeah, so to center it, I'm just going to change the fill rect call. I take my intersections XY location, that's the lower left corner, and I'm going to subtract another XY point from it, which is X is width by 2, height is, and height by 2. If I subtract that, I basically move the corner of the fill rect over by width divided by 2 and height divided by 2, and now it's centered. There's lots of different ways I could code this. Okay, so if you kind of go, wait a sec, what exactly is that doing? It's basically I look at the point operators and I can do it this way. Many different ways I could have directly changed the X and Y, whatever I want. Okay, and now I call the fill rectangle with that. And if I do that, that's going to be enough. It's actually going to work well now. So let me go and show you that. So I'm just going to take out this. Whoops. Take out this call and instead make this call. And all I changed is that little bit of drawing code. Okay, now if I go look at what happens when I click on things. I mean, it's always now getting what I expect. Okay, so if you watch that, you'll see it's always getting what I expect. I mean, sometimes I get something that's kind of partially hidden because there's another intersection in front of it. If I don't like that, what can I do? All right, so it's always selecting the right thing. It's just sometimes there's an intersection partially overlapping it. So I don't see the full highlighting. If I don't like that, how can I fix that? What do you think? How do I make sure something is always visible, even if there's other stuff around the same location? So I could draw it last. Right now, I just go and draw all the intersections in order. If I wanted to, I could basically make a loop go through twice. Go through, draw all the intersections, and then go through again and draw the highlighted ones. And if I did that, my highlighted ones will come out on top. So not very hard. Maybe if I did that, instead of storing a highlight Boolean on every single intersection, maybe I should just store a vector of highlighted intersections. So I'll draw all the intersections in black, and then I'll just draw the highlighted ones after. So you can do that too. Maybe I actually kind of like that organization of my code better. But that's basically, one of the other tools you can use, which is drawing order. Okay, and let's see. Yes, this is a long tutorial. Sorry, I've got a couple more things. So what I'll say is, if you got to go, and this will be recorded. For those who just arrived, you're going to get a modulo tutorial. You're going to see the end of this tutorial, and then we'll go back to the beginning for the next hour. So, okay, let's say I want to add some buttons. Okay, so EasyGL makes it pretty easy to add buttons that look like the existing buttons. You can also add kind of anything you want using GTK widgets, but that takes a little more work. So to add just buttons that look like the current EasyGL ones is pretty easy. So let's say I want to make a special feature called Pinkify. So when you click on Pinkify, the background turns pink. What do I need to do? I need to first create the button. And to do that, I'm going to use this initial setup callback. So I'm going to register that there's some extra setup code to call. In that initial setup callback, I'm going to create the button. Okay, and that's easy to do. And I'm going to tell it every button you create needs a callback. So when it's clicked, what do you call? I'm going to connect it to a callback as well, okay, called toggle pink. And then I need to have some state. that says, am I supposed to draw with a pink background or not? So I'm going to make a global variable to store that. And I'm going to call it Pinkify. And then I'll change my redraw function to decide whether or not to do this. So how does this look? I make an initial setup callback, call it anything I want, but then I have to write that function. That function gets called once when the graphics are being set up. And all it does is it calls in the EasyGL application, it calls create button. I give it a name. I say which row I want it in. So I want it to be this in the 6th row of my buttons. So there's 0, 1, 2, 3, 4, 5. Leave those alone. Insert this after the row 5. And I give it a callback. When it's clicked, call this function. EasyGL will take care of the clicking. It'll call you whenever it's clicked. You don't have to do anything. When it's clicked, this is what I want to happen. Okay, and the callback has to have this signature. So it takes a pointer to the GTK widget, which is the button that I created. I don't have to do anything with that, but I have to put it in the function signature. And it gets the EasyGL application in case I need it. And all I do here is basically I change my global variable. I have this Pinkify global variable. I basically invert it. So if it was true, it becomes false. If it was false, it becomes true. And then I say refresh the drawing. Okay, so force a redraw. Okay, and then my redraw function, I basically say if this Pinkify global variable is set, and that's, it's a global variable. So I put it outside any function, and I chose to initialize it to false to mean when the graphics start up, don't have a pink background. I want to make the whole background pink, so I'm going to draw it first, and I want it to cover the whole graphics area. To cover the whole graphics area, I can actually call this get visible world to get a rectangle that basically is in world coordinates the size of my drawing area. I set my color to, this turns out to be pink, and I say draw a rectangle of that size. Okay, so that's going to color the whole screen pink. And I can show you what that looks like, and that'll be my last demo for this one. Okay, so let's see. Okay, so when I run that, you see I've got this new button called Pinkify. Okay, I click on it, my background turns pink. I click again, the background turns off. It stays there if I, zoom in and out. So it does exactly what it's supposed to do. Okay, it didn't take me very much code. And it is this is row 0, 1, 2, 3, 4, 5, 6. So it's in row 6. Okay, so it's pretty easy to add buttons if you want them to look like the current EasyGL buttons. Okay, maybe what I'll do is for those who can stay for a minute is I'm going to just basically show you the very last thing. Okay, let's see where to put this. Okay, notice what the name of this application is. So if you look at the top title bar, it says EasyGL example application. And on the marking rubric, we actually put in, this is not a very good name. Okay, so you should pick some name for your application that is better than this. So how can I change that name? That name's not actually set in your code. So if I go to libstreetmap/resources, so not in source, resources. Resources is where you put like, PNG files, other things that are data. There's this file called main.ui. It's human readable, and it defines your UI layout. And you'll actually see this EasyGL application examples in it. Okay? You could directly change that, but usually what you do is you use an editor called Glade. So I just type Glade main.ui. And basically, this is how the UI layout was created. So inside here, basically, I can look at the various UI elements and how they've been arranged. Okay, so this main window corresponds to the whole window. This inner grid, for example, corresponds to the area where we put buttons. And there are specific buttons like the zoom info button and so on, or zoom in button and so on. But click on main window. Over here on the right-hand side, I can edit its properties. I turn off this client-side window decorations, and now I can change the name. So I'm going to change this name to 297 Super Good Map 100%. Okay? So I'm going to tell my TA, in case he or she is confused, just give me 100%. Okay? In case they're highly suggestible. I hit the save button, and now that's been saved. So let me bring back up the, let me bring that back up, and I run my mapper again. Whoops, got to go back up. Okay, and now you see the title of my map is basically tells my TA to give me 100%. Okay, you might want to be more subtle. You just imply to your TA that he or she should give you 100%. You don't have to directly tell them, be subliminal. You can do more than that in Glade. Okay, so I just showed you how to change the name, but basically you can change anything you want, right? You can move around the buttons, you can delete the buttons, you can add new GTK widgets. You do not have to do any of that. So change the name, because we put it on the rubric to see, did you pay attention? But you don't have to do any more stuff with GTK if you don't want to. If you do any of that, it's considered an extra feature. Okay, so only do that if it's fun for you. If you're busy with your other courses, don't. That's it for today. So sorry for going a few minutes over.